In today's video, we're going to be talking about x-intercepts, y-intercepts, slopes, rise, run, all that kind of stuff that comes from Blitzer's Introductory to Intermediate Algebra for College Students. That's the book that we're based on. So, Chapter 3, Section 3. So the first thing we want to do is calculate the slope of a line. The slope of a line is basically how steep a line is. If you think about going snow skiing, then the steeper the hill, the more difficult the ski might be to ski down or even to climb up or to go up if you don't have a lift. If it's not as steep, it's sort of more flat, then that's a less steep line or less steep slope, okay, or hill. You can also have no hill at all, okay, so that would be like flat, so that wouldn't be very fun skiing, but it would just be maybe a little easier to get used to your snow boots. And then a complete vertical drop would have a slope that's undefined. We'll talk a little bit more about that. So when you have a slope that goes uphill or rising, it's going to have a positive slope. When it's going downhill or falling, we call that having a negative slope, and we actually can calculate it. If we have a hill that is flat or a line that is flat, it's not going up or down, that means that there's no slope or a zero slope, similar to if you had no money in your pocket, you have zero money in your pocket. So no and zero mean the same thing. And undefined is not the same thing as no or zero. This is like if you were trying to ski down this, that means you fell all the way down off the cliff and then you go to the hospital and things are bad. So there's no slope to that. Okay, I mean, it's not a number, it's called undefined. So there's a formula for slope. There's several of these if you notice. Slope is the same thing as the letter M, which is the same thing as rising over running, which we'll talk about, which is the same thing as the difference of y's over the difference of x's, which is the same thing as delta y over delta x, and this is the same thing as saying change in y, change in x. So there's a lot of different ways to represent it, even though they all mean the same thing. Remember that when you're rising, you're going up or down, and when you're running, you're going left or right. Okay, so basically, if you have an equation for a line, and it's already in this form, if your equation already looks like y is equal to stuff, y is equal to stuff, y is equal to stuff, it's kind of nice because the coefficient in front of the x is your slope. You don't have to do any math. So here, I already know my slope because it's 3. It's the number right before the x because y is isolated. Y is isolated here, so my slope is 5/3. Y is not isolated here, and it's not isolated here or here. So because it's not isolated, I have to rearrange the formula before I can look at slope. I have to do a little math. Okay? So if it's already in this format, the slope is just the number right in front of x. Okay? Slope is a positive number if it goes uphill, negative when it goes downhill. Horizontal lines have no or zero slope, and vertical lines are undefined. It's not the same. Undefined is not the same as zero. All right, so what did I say just a moment ago? If it's already in the format that y is isolated, whatever the coefficient is in front of the x is your slope. So 3 is your slope. 1/4 is your slope. -2 is your slope. 5/3 is your slope. We already know it because it's just the coefficient right in front of the x. This one, we don't have a coefficient in front of the x because we haven't isolated y. So we need to rearrange this equation so that y is isolated. Now, when I divide this side by -9, I get y. If I divide -6x divided by -9, a negative divided by a negative is a positive. And an 18 divided by -9 is -2. Now, 6x over 9 is the same thing as 6/9 x. Okay, so don't get too hung up on the fraction part because the x and the 6 are in the numerator and the 9 is in the denominator. That hasn't changed. Now, this is a fraction that can be reduced by dividing the numerator and the denominator by the same number. We want the lowest, simplest fraction. So 6 divided by 3 is 2, and 9 divided by 3 is 3. and so we can reduce it. Now I have the format that I was talking about up here. I've isolated y, so the slope is just the number in front of x, just like I did here. Similarly, I can do the same thing here. So y is equal to x over 4. If I take something and divide it by 4, it's the same thing as saying having 1/4 of something. So x over 4 and 1/4 x are the same because the x and the 1 are still in the numerator and the 4 is in the denominator. We will simplify 6 over 4 by dividing by 2. So my slope is 3/2 or 1.5. We typically write slopes in fractions because later you'll see that fractions work with rises and runs a whole lot better than decimals. So, all right, so again, I can't just look at this and tell the slope because it's not in the right format. This is actually called the slope-intercept format because you can easily see the slope and the intercept, the y-intercept. So we're going to have to do a little algebra to isolate the y. So we can divide this by -1 and this by -1. So y, -2 divided by -1 is +2. And +5 divided by -1 is -5. So the slope here is 2. All right, try these. Here are the right answers. Okay, now we're going to talk about just looking at the graph. And before we start calculating a bunch of slopes from the graph, which we'll do in just a moment, we want to generally guess or predict, rather, whether the slope of this line is going to be a positive slope, a negative slope, a zero slope, or undefined, just by looking at it, doing no math. So if we look at line A is going downhill, so we know that downhill means that there's going to be a negative slope. Now this might seem silly to do this exercise, but believe it or not, when you get to doing the math, students make errors in the math, and if you don't make the prediction first, when you get your answer and your answer is positive, when you clearly know that the slope should be negative, it can help you go back and fix your errors. So A is negative. Line B, this is where you, it's not a zero slope, but you fell off the cliff and landed and broke your leg. This is undefined. Line C, this is going uphill, so it's a positive slope. Line D is also going uphill. It's just less steep. Please keep in mind that this is going uphill and this is going uphill. Both C and D are going uphill, but C is steeper than D. D is not as steep as C. So line E, there's no slope. Or you could say zero slope. That's fine. And line F, this is going downhill. So this is a negative slope. All right, you predict the ones on the right. Here are the answers. All right, let's talk about actually calculating the slope. So we're going to do a prediction and then we'll calculate. So we want to calculate the slope of each of these lines. So line A is here. It's going to be negative. I'm going to predict that it's a negative slope. Line B is going uphill, so I'm going to predict that it's positive. Line C is flat. There's no slope or zero. And line D is undefined. So I already have information without doing any math, but it actually asks us to calculate the slope, not just predict if it's going to be positive or negative. You actually have to use rise over run. Now the way to use the rise over run on this formula on a graph is to pick 2 points on the line and then go from one point to the other point by rising, then running. That means go up or down first, then left or right, which is backwards than a point, by the way. When you have a point, you go left, right, then up, down. Slope is the opposite. You go up, down, then left, right, okay? So let's look at line A. Now the key here is to choose points that are actually, you can read accurately on the graph. So like this point crosses exactly where I know that x is -4 and y is 4, like it crosses perfectly. I wouldn't want to choose this point because it's too hard to read the graph. I don't exactly know what that is. Is that -2.6? Is that 3.3, 3.4? What is that? I don't know. So it's important that you choose points, 2 points on the line that cross at integers so that you can easily determine what the rise and the run is between the 2 points. Now remember, the slope on this line is the same no matter where you touch, okay? So the slope here, the steepness, is the same as this steepness, which is the same as the steepness if you went on forever and ever and ever. So choosing any points doesn't matter. You can choose any points on that line as long as you can read them accurately. So I see this point I can read accurately, and this point I can read accurately because it crosses at a grid line. So what I want to do using rise over run is to go from one point to the other point on the line, going rising first, then running. So if I went from this point to this point on the same line, I'm going to rise up 1. So since I'm going up, it's positive. Divided by, I'm going to run, meaning going left and right, left 2. Well, what do we know about going left? We know that it's negative. So I went up 1, and then I went left 2. Okay. So that means my slope is -1/2. Well, I predicted a negative slope, so chances are I'm right. Well, you might say, oh my goodness, what if I chose a different one? It doesn't matter. If we chose these 2 points down here, I could go up 1 and left 2. I'm still going up 1 and left 2. Even if I chose these 2 points, I would go 1, 2, 3, 4 up, which is positive, and then 2, 4, 6, 8 left. And guess what this reduces to? So any 2 points on the line, it doesn't matter. Just keep in mind that you're going to do the rising first and the running on the bottom. So let's look at line B. I'm going to choose 2 points that I can easily accurately read. I can read this one doesn't really cross this until I get here, okay? So I'm going to go from this point to this point. So I'll rise 1, 2, 3, 4, 5. And since I'm going up, it's positive. Now I'm going to go 1, 2 right, and 2 is right, so that's positive. So my slope is 5/2, which is a positive number, just like I predicted. Even if I went the other way, I would get the same answer. Let's say I wanted to go from this dot down here. It's okay. 1, 2, 3, 4, 5. I went 5 down, so that's -5. And then 2 left. That's -2. So my rise over my run would be -5 over -2, and a negative divided by a negative is a positive. Okay, let's look at this one. Choose 2 points. I go up or down 0, and I go left or right 1 or 2 or whatever. No matter what 2 points I choose, I'm not going up and down, so my rise will be 0, and my run will be some other number, and 0 divided by a number is always 0. Here, on line D, I go up or down, let's say 1, but I don't go left or right, so my run is 0, and you can never divide by 0, which is why this is undefined. Let's take a look at the answers to the other side. All right.